Okay. If there are no questions on any of the assignments, what we're looking at today is simplifying a complex fraction. Now there's two methods to go about doing this, and I think some of these have shown up on an ACT that y'all have taken before because they look kind of like this here, where we have a fraction inside of a fraction with variables. Now unfortunately we can't type this into a calculator, or at least the ones that are allowed on the ACT, because the TI-84 need to have a value for x. The TI-89, which is banned on all ACTs, could do it. There's two ways to do it. The first way, if necessary, simplify the numerator and denominator by writing each as a single fraction. Then divide by multiplying the numerator by the reciprocal of the denominator. Or two, multiply the numerator and denominator by the LCD of every fraction in the numerator and denominator, then simplify. So we'll go over method one first. I would watch this way. So you don't have to follow or write this down, because most likely most students like method 2 over method 1. I don't think I have yet defined one student that prefers method 1 over method 2. Because method 1, what we're going to do is we need to simplify the denominator into a single fraction. So we need to add those together. But to be able to add those together, we need the denominators to be the same. So we'll have 5 over x plus 4. Denominator, we have 1 over x plus 4 plus 2 over x. So in each one of the denominators, well, I need to get them to be the same. Well, the x plus 4 needs to have an x, so we'd have to multiply by x over x. And the 2 over x, well, it needs an x plus 4, so I'm going to multiply it top and bottom by x plus 4 over x plus 4. Now, if we do this, well, the numerator is actually going to stay the same. It's going to be 5 over x plus 4. Now, the denominator, the first one here, well, we'll have x, because 1 times x is just going to be x. And the denominator is going to be x times x plus 4. Now, again, with any of these addition subtraction, we don't want to multiply through the denominator. So the x times x plus 4 will leave as that. We're not going to distribute the x through to get x squared plus 4x. We'll just leave it as this here. Now for the numerator, we will multiply through. 2 times x is going to be 2x, and 2 times 4 is 8. Any questions on this so far? Okay. Now the numerator is still 5 over x plus 4. Now at this point here, we can actually add the numerators of the denominator, because the denominators of the denominators in the denominator are the same. They're both x times x plus 4. And here x plus 2x is 3x plus 8. Well, now we have a fraction, 5 over x plus 4 divided by 3x plus 8 over x times x plus 4. So I have two fractions being divided. Right. Really don't need that. So what we're saying is that I have 5 over x plus 4 divided by 3x plus 8 over x times x plus 4. Well, whenever we divide two fractions, we change it from division to multiplication and flip the second. Well, really, when we multiply, we'll put them on the same fraction bar. I knew I had one too many fives. Because this here should actually be 3x plus 8. Well, here the x plus 4 and x plus 4 will cancel out, leaving us with what on top? 5 and x. On bottom we have 3x plus 8. Now there's not a greatest common factor between 3x and 8, so we can't factor anything out. And the 5x and 3x won't simplify because the 3x has the plus 8, making it a single term, which means this here is the final answer. All right, I'm going to write this over here on the sideboard. 5x over 3x plus 8. Because that's what we got as the final answer, yes? Okay. So we had all this here. I'm going to erase it all. I'm going to move on to method 2. Now, just looking at the numerator. If I just look at the numerator, what would happen if I multiply, you're right, this by x plus 4? If I multiply the numerator, just the 5 over x plus 4 by x plus 4, what would happen? I would just have 5. Because we treat this as 1 over, and these here would cancel, leaving me with just 5, yes? Highlighter back out. Big highlighter. What would happen if I multiplied the 1 over x plus 4 by x plus 4? You would just have 1, yes? Well, what would I need to do to get the 2 over x to do the same thing? To just have 2. I would need to multiply by what? By x. Because 2 over x times x would just leave me with 2, yes? Well, so realistically, if I multiplied the numerator with an x plus 4, it would simplify out all the fractions, yes? And if I multiplied the denominator by an x plus 4, well, it would simplify one of them, yes? But what else would I need? I also need an x, because the single x will take care of the 2 over x. The x plus 4 would take care of the two others, yes? So we can actually use this least common multiple for these three fractions, which is x times x plus 4, to simplify some things. And whenever we do this multiplication, because x times x plus 4 over x times x plus 4 is just 1, because we're multiplying it again by 1. And these here will multiply with every numerator in the numerator and denominator of this complex fraction. So for the top, the x plus 4, x times x plus 4 is being multiplied with the 5. So we'll have 5 times x plus 4 over x plus 4. In the denominator, well, for one of them, we're having x times x plus 4 times 1, which is just x times x plus 4 over x plus 4. Plus, here we're going to have 2 times x plus 4 over x. Well, let's see what simplifies out. Well, here the x plus 4 and x plus 4 will cancel. So what we have left in the numerator is 5x, yes? You can put it on my desk. In the denominator, here the x plus 4 and x plus 4 will cancel. So I would have x plus, over here the x and x would cancel, leaving us with 2 times x plus 4. Yes? Okay. Any questions on how we got to this point here? Now we do need to simplify the denominator a little bit, because the 2 times x plus 4, we might have some like terms. So we can multiply that out. Which is x plus 2 times x is 2x plus 8. Well, yes. We can add the x and 2x, which give us 3x plus 8. Is that the same thing we got going the other direction? So, I'll ask the same question I ask every year. Which method do y'all prefer, 1 or 2? Y'all prefer the way we just did it, method 2? Yeah, and most do, because this here, using this, well, come on, and it wouldn't leave a massive line right through it. One more time, there we go. Using this multiplication here really simplifies everything down a lot, doesn't it? Because the other way isn't too bad, it's just that we have to get these two here to be a single fraction. And it would be a little bit even more tedious if we had to do it for the top and bottom and then change it from division to multiplication and do it that way. We're multiplying this by this least common multiple, actually simplify things a lot and a lot quicker. Questions on this here? All right. Let's look at the next one. And that last one's the last one we're actually going to do by the first method. Because for the rest of the notes today, we're going to use method 2. Partly because I don't think any of y'all are going to use method 1 ever after seeing method 2. So, what we want to do by method 2 is to get all of the fractions in this complex fraction to simplify. So what would we need to multiply the top and bottom by? So x over x and x minus 2 over x minus 2. Well, x minus 2 appears how many times in this fraction? Twice. Do I need it twice? No, because how many times does it appear in each fraction? Once, because it only appears once in our 6 over x minus 2 and only once in our 1 over x minus 2. So the only way I would need it twice is if in any of these fractions it appears how many times? Twice. So here we just need x times x minus 2. So we multiply the numerator. It would scroll. There is some gesture, I have a feeling, that I am inadvertently doing that's causing it to scroll. I have a feeling it's picking up either my elbow or hand and 2-finger gesture scrolling. Now the numerator here would be 6x times x minus 2 over x minus 2. The denominator is going to be x times x minus 2 over x minus 2 plus 3x times x minus 2 over x. Well, there are a few things that simplify, and we hope there would be. Because here the x minus 2 and x minus 2. Here, x minus 2 and x minus 2. And here we have the x and x. Which leaves us with 6x over x plus 3 times x minus 2. Now we will need to distribute the 3 across the x and negative 2. That leaves us with x plus 3x minus 6. Now x plus 3x would give us minus 6. Now at this point here on the last one we stopped, didn't we? But there's a reason we stopped on the last one. Because the denominator, wrong direction, on the last one was 3x and 8, yes? And we said there's no greatest common factor between them, so we were done, yes? And if we look at this one here, well, turn the page a little bit, 4x and 6 doesn't have a greatest common factor, correct? There is one actually, it's 2, yes? Now if I factor the 2 out, I have 6x over 2 times, almost got it, 6x over 2 times 2x minus 3, yes? Can we simplify the 6 and 2? Yes, because the numerator only has a single term. There's no addition and subtraction. The 2 that we have out front in the denominator is being multiplied, not added. So we can simplify the 6 and 2, which leaves us with 3x over 2x minus 3. 3x over 2x minus 3. Well, we took it out. Yeah, I think that's what you were going to say, yeah? Because 6 over 2 reduces to 3 over 1. And that's part of the reason why we factored it out, was because we could do that simplification. Any questions on this here? And that's also why, even if we did have like 6x plus 4 on top, and we can factor greatest common factors out of both, we want to do that to see if we can simplify top and bottom. But 3x over 2x minus 3 is the final answer. Any questions on this here? All right. Let's look at the next one. 6 over x minus x over 3 divided by x over 5 minus 7/10. Well, we can still do the same thing. But this time we're not looking for a least common multiple that has a variable or a set of parentheses. Because all 4 denominators in the numerator and denominator are all what? All numbers. They're all numbers. So we're looking at 6, 3, 5, and 10. What is the smallest number that I can turn all of these into? So 3, 6, 5, and 10. So we know that the number we're looking for has to be greater than 10. Yes? 30. When I did this here, the first number I jumped to was actually not 30, but 60. Because I did 6 times 10 and got 60. Because if we look at this here, 6 and 3, well, 3 is going to be a multiple of most 6. 5 is a multiple of most 10, so 10 and 6 gave me 60. But the issue is I actually have a factor of 2 extra. Now, we could have looked at this and done the factors of 3, 3, 6, 9, 12, 15, 18, 20, well, 21, 23, it should have been 24, 27, 30, 6, 12, 18, hold on, 18, 24, 30, 36, 42, 5, 10, 15, 20, 25, 30, and, well, 10, 20, 30. So 30 is the smallest. Now, if you'd use 60, like I did, when I looked at this the first time, that wouldn't be an issue. You would actually still be able to solve it, but at the very end, you'd have to factor out a greatest common factor of 2. Because we added an extra 2, so we'd have to pull it out in the end. Which for here, really wouldn't be an issue. Because it just makes all of them 2 times bigger. If we had variables, that makes it a little bit more tricky, because if instead of having x squared, like on the last few where the greatest power of x was just to the first power, adding an extra factor would actually, instead of being x, it would have been x squared. Every one of them would have increased by a power of 1, or added an x. Now, really what we need to do here is multiply each one of the numerators by 30. So on top, we're going to have 30x over 6 minus 30x over 3. On bottom here, 30x over 5. Okay. Nope. Okay. Sorry. 30 times 7 is going to be what? 210. Because 7 times 3 is 21. We added a 0 for 30, which gives us 210. Now we need to simplify each one of these here. Well, 30x divided by 6 is going to be 5x minus 10x, because 30 divided by 3 would be 10. 30x divided by 5 is 6x minus, okay, good. 210 divided by 10, 21. Dividing by 10 and multiplying by 10 are nice. Now, in the numerator, 5x minus 10x is negative 5x. 6x minus 21, well, 6x minus 21, we can't combine those. But they do have a greatest common factor of 3, so we can actually pull that out. Which will leave us 3 times 2x minus 7. Now, we didn't necessarily have to factor that out. I do. I think it's a good habit to do, just to make sure there isn't a greatest common factor on top and bottom. Will anything actually simplify by pulling that out? No. Because the 5 and 3 don't have any greatest common factors. So really, this here is the final answer. That's all we have to do. Now, probably, and most likely, actually not most likely, the textbook will do this, so if you look in the back, here it would have left this as negative 5x over 6x minus 21. Because it doesn't simplify, it leaves it in that form. I think it's still a good habit to get into, to go on and factor it and see if it does simplify. If not, we can leave it as that there. Because a lot of them on the last homework assignment with addition and subtraction or multiplication and division, if it didn't simplify, they didn't factor it. So if you do look at the answer keys for those, they still have them in their parenthesis form, or as quadratic form, not in the factored form. But I still think it's good to have it factored. Any questions on this here? Let's look at this one here. So we do need to multiply the top and bottom by the same thing so that we reduce the fractions out completely in the top and bottom. Now looking at this here, what would I need to multiply the top and bottom of this by? X and X, yes. Do we need anything else? For the 4 and 3? Yes. So the 4 and 3 do have a denominator of 1, yes? But dividing by 1, does it change anything? No. And do the 4 and 3 actually have a fraction? Are they in a fraction? Not besides the complex fraction what we already have, yes? So do I need to even worry about the 4 and 3? No. And that's exactly why I put this in, to see and come across this. Because up to this point, everything in the numerator and everything in the denominator was a fraction, yes? We had multiple fractions. This is the first one where we actually have two terms that aren't. So I'm not even really concerned about the 4 and 3. I'm just more focused on the 2 over x and 2 over x. Because if we multiply through by this x, well, we would get 2x over x minus 4x. In the denominator, we would get 2x over x plus, and well, x and x cancel, leaving us with, well, negative 4x, okay, negative 4x plus 2, and I flipped them because I like having the variable first. That's all we did. We put the negative 4x first. Since the sign in front of the 2 is positive, it's just going to be plus 2. And the denominator, we're going to have 3x plus 2. So really multiplying by the x did eliminate every fraction in the numerator and every fraction in the denominator. And we get this here. Well, the numerator does have a greatest common factor, and we can pull it out. There's a greatest common factor too, but we can also pull out the negative. And I pull out the negative because the sign in front of the x is negative. And I like having the variables be positive, the highest degree of the variable, which in this case would just be x because we don't have an x squared, which would leave us with 2x minus 1. Because when we factor the negative, the signs all flip. So since the x was negative, it's now positive. Since the 2 was positive, it's now negative. And 4x divided by 2 is 2x, and 2 divided by 2 is 1. And it's over, well, 3x plus 2. Because the denominator, we can't have a greatest common factor or anything of the such. Now, did we have to factor out the negative? Well, no. I mean, I could have left it as 2 times negative 2x plus 1 over 3x plus 2. Either one works. Because if it did work out that the denominator was negative 2x plus 1, I would just factor the 2 out and those would cancel. Or if there was a negative 3x minus 2 on the bottom, we can factor both negatives out and they would cancel. So really, either one of these I would take because they are the same thing. Or as we said earlier, the textbook would actually just leave it as I am doing some kind of gesture to get that. Don't know what. this here, because there is no greatest common factor in top and bottom, so they'll leave it here because it won't simplify. Mm-hmm.
Yeah, it was 2x over x.
Mm-hmm.
So
Mm-hmm.
it should be 3x minus 2.
Well, since in either case it's still positive over here, I only took the negative out of the top two.
But from that equation, aren't you subtracting the 2 behind the 3x?
Because I just reordered them. It would be if this was a negative 2 over x. Because the sign in front of it's positive, or really there is no sign. It's understood to be positive. Because here, it's really saying that we have 2 plus 3x, which would be the same as 3x plus 2, because they're both positive. Does that kind of make sense? Yeah. The only reason it worked that way in the numerator is because I have 2 minus 4x, and the 2 is positive. So if I flipped it, it would be negative 4x plus 2. Does that make a little more sense why that worked that way? Mm-hmm. Yeah, no, good question. Any other questions on this here? All right. Any other questions on any of these here? We can look at one more of these here. Is there one of these that's left? Because there are a few that y'all would want to look at. Because we do have this one here, which I think y'all can do is not too bad. Yep. This one here. Mm-hmm. I'll tell you for this one here, if we were to do it, all we would need to multiply everything by is x squared y squared. And I'm not saying this because it would come up on an assignment, but just in case you wanted to work through it, that's what we would need to multiply by. This one here. I will guarantee you that it's not going to work out to be 1. So it's not going to be frustrating like that, because those are some of the more frustrating ones where you do all the work and then it's like, hey, it's 1. So looking at the numerator and denominator, what do we need to multiply top and bottom by so that the 4 fractions will simplify out? Yes. And we only need each one once because each one only occurs once, one time in each of the 4 spots. After this class, I really need to resize that down because I don't quite have enough space to write the next step underneath without actually seeing the whole problem. That's the only reason I would say that. Now, for our first one, in the numerator, we already have an x minus 1, and we're multiplying it with an x minus 1 and x plus 1. And it's over x plus 1 minus. Well, this one here has an x plus 1 to begin with, and we're multiplying it by an x plus 1 and x minus 1. And I know I did flip the order of those, because on the first one I said x minus 1, x plus 1, x plus 1. Likely with multiplication, how we multiply any 3 things really doesn't matter, as long as we don't change what we're multiplying. On bottom, we started out with an x minus 1 on top, and we multiplied it by our x minus 1, x plus 1. And this here is over x plus 1. And lastly, we started out with an x plus 1 and multiplied it by an x minus 1. And x plus 1, and it was over x minus 1.
How do we
Yeah, because whenever we multiply any three things together, as long as I don't change one of these to x plus 27, we're good. Now, x plus 1 and x plus 1 would cancel here. X minus 1 and x minus 1 would cancel. Here, x plus 1 and x plus 1. Here, x minus 1 and x minus 1. Which incidentally, and kind of interestingly enough, leaves us with x minus 1 times x minus 1 minus x plus 1 times x plus 1 over x minus 1 times x minus 1 plus x plus 1 times x plus 1. Now, I find this interesting because in each of those four spots we end up with the same term twice. X minus 1, x minus 1, x plus 1, and x plus 1. X minus 1, x minus 1, x plus 1, and x plus 1. Now for space, because I do know that y'all are running a little short on it, yes? What turns out for x minus 1 times x minus 1 and x minus 1 times x minus 1 is going to be the exact same thing. So if I write it out here to the side, x minus 1 times x minus 1, well, x times x is x squared minus x plus 1, because x times negative 1 would be negative x. Negative 1 times x would be negative x, and negative 1 times negative 1 is 1, so that gives us x squared minus 2x plus 1. So over here, in both of the first terms, we get x squared minus 2x plus 1. Okay, I'm going to erase this because in its place, I'm going to do the other setup, x plus 1 times x plus 1. If we do this here, we'll get x squared plus x plus 1, which is x squared plus 2x plus 1. Now for the denominator, we can just put x squared plus 2x plus 1. But the numerator, it is being subtracted. So we have to kind of put the parentheses around it just as a reminder to ourselves that the signs inside those parentheses are going to change from positive to negative or negative to positive. And it's about to get a lot smaller. So in the numerator, I'm just going to change the signs of the second, so distribute that negative. So we would actually get negative x squared minus 2x minus 1. We're just making those negative. Now the denominator, we don't have any parentheses, so we can actually go on and combine like terms. X squared plus x squared is 2x squared. Well, negative 2x plus 2x is 0. And lastly, 1 plus 1 is plus 2. Kind of nice. Now the numerator, I have x squared minus x squared. 0. Those are gone. Negative 2x minus 2x is negative 4x, yes? I took up all the space in that numerator, didn't I? But our last one is 1 minus 1. Okay, that worked out just fine, didn't it? Now the denominator, we have 2x squared plus 2, yes? I can factor out a 2, which will leave us with x squared plus 1. And last but not least, the 4 and 2 would simplify, give us negative 2x over x squared plus that is it. Any other questions on this here? There's this fancy looking one. I don't have time to work this one out.
X won't haunt you in your dreams.
No. But this here is the huge assignment for today.
Oh my gosh, just
Were you looking at the other one?
so he wrote a bunch of X's.
Now, this is the homework assignment. The last one there, the one that had x plus 1 squared and x minus 1 squared in the denominator, I did work that one all the way through for third hour. So it is included in the video if you want to go back and look at it. And it actually reduces down to x squared minus 1, incidentally enough. But you only have 4 problems for this assignment.